Okay, so we've now reached part 5 of our lab. We're going to start tinkering with bandwidth uh, settings. Essentially, we're sort of tuning the implementation just a little. We're changing the metrics. Um, the title of the section is Change OSPF Metrics. I said in previous video that part 5 would be implementing OSPF um, authentication. That must be a bit of a typo in the document itself because we're not doing that. In fact, OSPF authentication, I'm not sure is even in the portable command guide. But speaking of the portable command guide, a lot of the commands you will need, the ones I've discussed already, and some others which I haven't discussed, which we may touch on as we go along. These are all on page 148 and 149 of the portable command guide. I realize it's backwards. You should have this book already in hard copy, Dead Tree Edition, or soft copy on a portable device like a PDF on your laptop or an iPad or an Android tablet. If none of those things is true, you need to fix that. You do have, at least for the moment, access to this via Moodle in Redshelf, but eventually your access to Moodle, I think, and to Redshelf will go away. I know that Redshelf will go away in about 6 months, possibly a little bit less. You may get into Moodle a little bit longer, but don't rely on these online resources. What happens if you lose power? What happens if you go someplace where you have to get your job done and there isn't an internet connection? Because either you're trying to put something back into service so there can be an internet connection, or you're out in the country and the fastest connection available is, say, VSAT, a satellite link, or 56K dial-up, something like that. It is always good to have things like this available in some format that does not require batteries. If you have to read it by flashlight because you're in a dark and poorly lit wiring closet, then it sort of kind of requires batteries. But the book itself shouldn't require batteries. If it is that important to you, do not rely on external power, period, full stop. So let me get off that particular soapbox and back onto the lab. What we're doing now, we're going to change the OSPF metrics so that this works a little better. We're going to look at the bandwidth interface command, the IP OSPF cost router command, and the auto cost reference bandwidth command. So I'm going to start on router 1. Let me get back into it and find my, okay. Actually, so what I'm going to do first is show interface gig 01, gig 00 rather. Let's look at what this looks like now. So show interface 01, boom. So show interface, of course, is a layer 2 command. What is it doing in terms of the hardware, in terms of frames and errors, its encapsulation, its bandwidth? As we can see, its bandwidth is a very large number, is 1,000,000 kilobits per second, which is to say gigabit Ethernet. One of the things you'll find on modern networks is that we're not simply using gigabit, we're often using 10 gig E. In the old days, the bandwidth reference setting was sufficient to differentiate Ethernet from serial lines, or fast Ethernet from serial lines. It doesn't do a good job, honestly, because the divisor is too small of differentiating between fast Ethernet and gigabit Ethernet and 10 gig E. If you look at the cost ratios for all those things using a divisor equivalent, sufficient to make fast Ethernet interfaces have a cost of 1, gigabit Ethernet also has a cost of 1. And 10 gig Ethernet also has a cost of 1. Because if the result of that division is a fraction, it will round up to the nearest whole number being 1. Obviously, a fast Ethernet port, in terms of its cost, is a lot less valuable than a gigabit port, which is a lot less valuable than a 10 gig E port. So we have to fix that. Let me look at my IP OSPF interface gig 00. So we've looked at it at layer 3. Actually, what we can do is show IP interface G0 hack 0. So we've looked at it at layer 2, and we've looked at it at layer 3. Now let's look at it for the protocol. I can see now in 10 gig, I see its interface, I see its broadcast, I see its mask, I see whether or not it has access lists, redirects, switching, router discovery, etc., etc. BGP, a lot of other fun stuff that we don't need to worry about right now. So what I see here is its network type, its state, its delay. It's not sending hello messages because it's passive. Technically speaking, a passive interface can receive them but doesn't send them. So what I want to do now is actually go into my router. T router OSPF1 and do auto cost reference bandwidth 10,000. The reference bandwidth command is stated in kilobits per second, or I'd strike that in megabits per second. So what I want to do essentially is set it to value a 10 gig E interface as a value of 1, which means that a gig interface has a value of 10 now. A fast Ethernet interface still has a value of 100 because it's 100 megabits per second. Okay, and now this note, make sure the reference bandwidth is consistent across all routers. Once we just start doing this kind of, we need to, so what this means is I'm going to have to do the same configuration on all the others, so they're all costing correctly. So I don't have router 1 costing a 10 gig gig interface at 1 and router 2 doing it at 10, etc. So I need to propagate this choice. So I can see the results of my changes in a couple of other places. I see that it is my bandwidth has now moved for my serial lines has now increased from my metric has increased from 65 to 6,477 because I've multiplied some things. Let me do this 0, 1. So I haven't changed. This doesn't change on my serial lines. Oh, actually, it does change. My cost here has changed. Has gone up a lot. So I've now changed everything everywhere. So do show IP route. And I did that with the auto cost reference bandwidth 1000 command. Or actually, that should have been 10,000. So this one is doing it a little differently. Let's make that 10,000. Absolutely, you want to make sure this is right all the way across the board so that these things are computing the right kind of routing table. So let me do that routing table again. See, my metrics vary wildly. If you add a 0 or you subtract a 0, things can change a lot. Setting this to 1000 would have set the base cost, as it were, to a gigabit port. Setting it to 10,000 would have set it for a gigabit Ethernet port. Setting it to 100, which is kind of the default, sets it for fast Ethernet. The lab has you do that. So go ahead and do that. And I'm going to move on to the next portion, which is to set bandwidth on the interface. Now, one very important point here. You set the reference bandwidth in the routing process. You set the bandwidth on the individual interfaces. What we're going to do is set the interface bandwidth on the serial lines to 128 kilobits per second. Be right back. Okay, so I have a before and after here. Before, I did show interface S00, and I had a bandwidth of 1,544 kilobits per second. In other words, a T1 line. Then I set the bandwidth to 128, and that cranked it down to 128 kilobits per second. And now, over here on a different router, let's do show IP route again. Notice that my interface is going through router 1 on S00. These metrics have cranked up a lot. No, just like that. Okay, so hold on. Okay, so I skipped a step. You really do need to set those reference bandwidths back to 100 megabits per second. Now my cost coming out of this serial line is 128, whereas, let's see, do show IP route. I've got I've got differences on my serial lines. I've got some at a 164, one at 782, 128. You set your reference bandwidth on that interface, and you basically dial its speed back, essentially. Now, that's not its physical speed. If you do go into the interface and do a no bandwidth command, it'll all go away again. Now, the thing about the clock rate, the other thing about the bandwidth command is it needs to happen everywhere. You can't, unlike the clock rate command, you can't set it on one side of the link and that applies to the other side. The DTE end of a serial line is listening for the DCE end to have its clock rate specified. With bandwidth, just like auto reference bandwidth, if you're going to make this change, you need to make it everywhere that is relevant. So in this case, I'm going to go to all of my serial lines. And I could even okay, I can't do interface range, unfortunately. That's a bummer. So now if I do show IP route again, I notice that all of my values have changed. I'm using my 10 gigs, my megabit as my base speed for Ethernet, despite the fact that there aren't any fast Ethernet interfaces anywhere on this topology. But that's okay. So I did that, and now the last thing you can do is change a route cost. So let me do that and come back. So what I'm doing here is tuning by placing an OSPF cost value onto an interface. I'm tuning it so that OSPF will choose one route over another. So show IP. So let's do show IP route again. And I can see that one of my serial lines has a value of 782 and the other one, despite the fact that they both have the same bandwidth settings on them, has a value of 1662. So it's doing the math differently. It will, if it has two routes to the same location, it will choose more. It will choose the one that is a little different, that is lower specifically. The lower metric in this case wins. Let's see, and now this is the easiest way to manipulate these route costs. It's a better idea than manipulating the bandwidth value on the serial lines. You also need to worry about setting up